Okay, welcome to our next class. In today's class, we are looking at integration. That's our topic for today. And then, given this question, let's see how we can evaluate this man. Integral of our limit is taken given to be minus 1 to 1 of x over x plus x. Now, if you see this kind of question, it's very simple to solve. Don't doubt, because here is x, then here is an x, here is x, and then you are thinking from. It's very simple to solve. First and foremost, what you do is that try to differentiate this denominator. If you see any integration that is a fraction, try to differentiate this guy. If this man, this denominator, give me what is at top, just take the mean of that solution. But in this case now, if you look at it, if I differentiate this man, I will not have this one. So what do I do? I'll try another method. So this man, let's take the solution. Know that integral of 1 to minus 1 of x over x plus x can also be x can also be written as integral of 1 minus 1 to 1 of x all over. Here is x cubed. I can factorize to be x into x squared plus 1 in x. Now, if you cancel this man and this man, you are wrong, because you don't know the final solution to this man. You don't know the final solution to this man. If you cancel this man and this man, you get your solution. You are wrong. So what do you do? If you look at the equation, this is x squared plus 1, this is partial fraction. Because you cannot integrate at this point. What do you do? Resolve this to partial fraction. Split the partial fraction. So partial fraction says splitting this into partial fraction. That means this might a, and this might be x. This might be x and c, because the degree is squared inside the bracket. X is squared plus 1. X squared plus 1 can be written as bx plus c. So taking the partial fraction, splitting the partial fraction, we have a over x plus this one, bx plus c over x squared plus 1. Because I said this man, if you are splitting x squared plus 1 to partial fraction, that will give you bx plus c, because the degree of x here is squared. Equates everything to what is on top. The x equates everything to what is on top. So that means integral of this man, same thing as integral of this. Integral of this can also be written as this. From here, what you need to do is just for you to find LCM. We find LCM so that you can get your value of A, B, and C. So if I find my LCM, or you can just cross multiply from here, cross multiply. That will give you A into x squared plus 1 plus bx plus c into x. If you cross multiply, then equate everything to this one, x. From here, what I will do is just open the bracket, then I get my value of A. So A times x squared will give me ax squared plus A times 1 will give me A plus bx times x will give me bx squared plus c times x will give me cx, all equals to x. My people, what I will do for me to get my value of A, B, and C is for me to apply the comparing coefficient. So if I apply the comparing coefficient method, that is x squared to x squared, x to x, constant to constant. Looking at this, I have x squared at A, also have at B. So I'll quickly factorize. That means x squared, let's compare the coefficient. X squared into A plus B. I'll look at this other side. Looking at this other side, x squared is not A. That means everything is equal to 0. Then apply the same method to x. At x, I already have x with c. So here will be c equals to, there's x at the right hand side, so it will be equals to 1. Then for constants, we have only a. Then look at, there's no constants here, that means our a equals to 0. So looking at this is just like say this is equation 1, a is equation 2, a is equation 3. So now looking at the equation, we have that our c, let's take our solution to be Looking at equation 3. Equation 3 says our A equals to 0. That means we are plotting our A. Then equation 2 says that. So looking at this, we are plotting our 3 equations. So what we are going to do is just to get our value of A, B, and C. So let's start from equation 3. Equation 3 says that our A equals to 0. That means our A is equal to 0 when we are plotting our value of A. Then let's look at equation 2. Equation 2 says our C equals to 1. That means we are plotting the value of C. Our C is 1. Let's check the equation 3. Equation 1. Equation 1 says A plus B equals to 0. You know that our A is 0. So that means it will be 0 plus B equals to 0. It's telling us that our B is also 0. Because once I make my this guy solving formula, I'm having that B equals to 0. So that means that means B is also equal to what? 0. B is also 0. From there, we can substitute inside this one. Quickly substitute our values inside it, then we integrate, then get our value. So if I do that, recording from here, integral of this 1 minus 1 from this man, that is A over x plus bx plus c all over x squared plus 1 and x. So from here, that will be written as integral of 1 minus 1 of 0 over x plus this man dx. Our b is 0, that will be 0x plus our c is 1 all divided by 1 x squared plus 1 dx. My people, this man can also be split into this integral of 1, this is minus 1, here it will be 0 over x plus 0x over x squared plus 1 plus 1 all over x squared plus 1 dx. This man can also be written as this man. So looking at this, 0 over x, this man will cancel out, this man is 0. 0 times x is 0. 0 divided by the whole of this man is also 0. So we end up having integral of 1 to minus 1 over x squared plus 1 dx as our final solution. My people, integral of 1 over x squared plus 1. Then you need to flash your mind to our standard trig function, inverse trig function. Remember, when we solve that inverse, we have this one. So that simply means integral of 1 over x squared plus 1 dx will give us tan inverse of x. Then you can put your limit from 1 to minus 1. And if you really want to know how we get this man, this tan inverse, this trig function, stay informed so that in our next class, I will prove this man that this man is equivalent to this man. And once you check my YouTube channel, you see I've resolved this man. Check my YouTube channel. You notice that this man is equivalent to this man. At the same time, this man is also equal to this man. Check my YouTube channel. Check it, you see it. I've solved it, you see it. So let's continue from here. If one really know the root of this man, check my YouTube, you see this man. That this man is equivalent to this man. So from here, let's penetrate our limits. So because we have gotten our integration, this is our final solution. The next step was to penetrate our limits. So that will give us tan inverse of putting the limits. Tan inverse of 1 minus tan inverse of minus 1. My people, tan inverse of 1 will give us 45 minus tan inverse of minus 1 will give us minus 45. Minus is plus 1. So 45 plus 45. So here our answer equals to 90. So my people, it simply means that what it means is that it means that integral of this man, it means that integral of minus 1 to 1 of x all over x cubed plus x dx is equals to 90. And this is where we end our answer for today, our class for today. And stay informed for more explanation based on our topic for today, integration. So that in our next class, we can look at if you look at this integration, we were given this integration is actually for the different integration because of the limits given. Arabian there was no limit, then we call it indefinite. So it's different based because of the limits given. And looking at the question, you notice that we resolve this into partial fraction. So that means we need to know partial fraction. Partial fraction is very important for you to know because the question, we resolve this question. Look at where it leads us to partial fraction. Then from there, we arrive at our answer. Then we can split, then we solve. So in our next class, we check more of this particular topic, integration based on partial fraction. Thank you. Check my YouTube channel. You'll see this man. This man is